Hello everyone. So today I just want to talk about memory allocators and why we even need them in the first place. First off, malloc is built to handle everything. Whether you're asking for 1 byte of memory or 1 megabyte or a whole gigabyte, it needs to be ready. That flexibility means it carries a lot of internal baggage, like tracking every block, checking for fragmentation, and making sure nothing overlaps. All that makes it slow, even for small allocations. Now think about this in a real game engine. Rendering, physics, AI, and audio. Each subsystem doing its job. All of them allocate memory at the runtime, often at different times and for different purposes. As the codebase grows, so does the number of allocations. With the huge codebase, keeping track of every allocation and ensuring it's properly freed becomes a nightmare. Miss even one, and it stays forever. That's a memory leak. So how can we avoid this chaos? That's where the memory arena comes in. The concept is pretty simple. Instead of constantly asking the system for memory, we reserve a large contiguous chunk up front and then hand out portions of the buffer to different systems as needed. No dynamic mallocs, and we don't track each individual allocation separately. Each system operates within its assigned slice, and when we're done, we just reset the entire arena in one go. This way, we significantly reduce the system calls like malloc from hundreds or even thousands to just a few. Now that we reserved a big chunk of memory, now comes the real question. How do we even use it? That's what memory allocators are for. Let's begin one of the simplest, the linear allocator. We start by initializing the linear allocator using an init function. This sets up our memory and gives us a starting pointer. Now we can allocate memory using an alloc function. This returns a pointer to the start of the allocated space, which we can now use however we want. Need more memory? Just call alloc again and you get a new pointer right after the previous one. But there's a trade-off. We can't free individual blocks. In a linear allocator, we can only reset the whole arena at once. So the linear allocator is simple and fast, but not very flexible. What if we want to free memory but still keep things predictable? That brings us to a second allocator, the stack allocator. We initialize this memory just like the linear allocator by reserving a big chunk up front. Then we call the alloc function and we get a pointer to the memory, just like before. But here's the difference. Along with the allocations, we can also place markers. These markers track where we are in the memory. At any point, we can call getMarker to save that position. And when we're done with recent allocations, we can call deallocateMarker, which frees memory back to the marker. It's just like stack, the most recent allocation or the first to go. This makes stack allocation perfect for nested or temporary allocation, while still being fast and easy. We know that the stack allocator gives us some flexibility, but what if two systems want to use the same memory without interfering with each other? Enter the double stack allocator. It's like having two stack allocator in one. One grows from the start of the buffer, the other from the end. In some situation, both stack might use a similar amount of memory and meet somewhere in the middle. In other, one stack might use significantly more than the other, and that's fine too, as long as their combined allocation doesn't exceed the total size of the shared block. This model works great when you need two lifetimes, operating independently but sharing a single memory block. We've seen allocators that gives us speed and flexibility. But what if we need to allocate and free many small objects and do it frequently? That's where the Pool Allocator comes in. The Pool Allocator is designed for fast, predictable memory usage, especially when you're working with same-sized objects as bullets, enemies, or any other game entities. We first configure the pool by passing in a block of memory, the allocation size for each chunk, and an alignment value. The init function aligns the buffer and adjusts the chunk size to ensure everything is aligned properly. Then it divides the buffer into an equal sized chunk and links them together into a free list. To allocate memory, we simply pop the first node from the free list. The allocator returns a pointer to that memory ready for use. This is incredibly fast, no complex bookkeeping, just grab the head of the list and go. When we no longer need a chunk, we call pool free function. This allocator checks the pointer is valid and inside the pool's bound. Then it pushes the chunk back to the front of the free list, making it available for the future allocation. There's a lot more to memory allocators than we discussed here, like free list allocators, buddy allocators, and more. We also haven't fully explored memory alignment or fragmentation. I added helpful resources in the description if you're curious to dive deeper. I chose this topic because I learned it on hands while building my own game engine. If you found it helpful or interesting, leave a comment below. I'd love to hear what you think. And yeah, thanks for watching. See you next time.